Welcome to another session of INF 164. So for this session we are going to continue with the rest of OOP stuff, more specifically polymorphism and interfaces. So let's get started. So let me handle this first. So yeah, let's get started. So let me open here. This was 272, so I don't want 272. Add section 164. So yeah, let's get started. This is polymorphism and interfaces. So yeah, so what is polymorphism? So we can divide this into two separate parts. We have poly, then we have morphism. So poly means many, then morphism means forms. So hence polymorphism, in simple terms, it's just many forms. So let's get into depth. What does it mean? This many forms. So let me change. I don't like this green, so let me change. So I'm going to use black. So let's get into the actual polymorphism. Yeah, like this. So polymorphism allows objects of different classes to be created as instances of a common class. So you are going to have a base class, then you are going to have different objects created from this class. So you have object 1, object 2, then you have object 3. So these objects were created from the same class. But what is actually polymorphism in this case, or how does polymorphism work? So in this case, polymorphism allows the base class to act as different classes. Actually, these are classes, they are not object. These are classes. They are also classes. So it allows the base class to act or to appear in different form. It can appear as class 1, as class 2, and as class 4. So let's try to break down this, because from the definition it doesn't really make sense, but let's consider a real life example. So let's say you have a woman as our class. So when you have a woman can appear as a mother to her children. Then they can appear as a wife to her husband. Then they can appear as a sister. So they can appear as a sister to what? To their siblings. Then they can appear as a daughter to their mother. So it depends on who's looking the woman. So the base class is the woman. Then different classes, the child classes are sisters, because in general when we consider sister, a sister is a woman. It's a relationship. Remember inheritance. So a sister is a woman, daughter is a woman, mother it's a woman, wife it's a woman. So this is inheritance. So not all women are sisters or can be sisters. Not all women are daughters. Depending on who's looking, and not all women are mothers, not all women are wives, but all wives are women. You cannot have a man as a wife, but to the current generation, anything is possible, but ideally that's not real. We all know we are just trying to accommodate other people, but in reality that's not true. So yeah, you are free to text me there and argue about this, but I don't want to argue, but you can state your points. But according to me, or to what I believe, is that all wives are women. You cannot have a man as a wife in reality. And also mothers, all mothers are women. You cannot have a man as a mother. That doesn't make sense. Same with all daughters are women. You cannot have a man who's a daughter of someone. He's the son of someone. So that's inheritance. So let's use realistic examples, because this one can cause arguments in most cases, but sometimes you just need common sense. So let's move forward. Then if I offended someone, I apologize, but this is just an example of polymorphism. Then let's consider an animal. So when you look at an animal can appear in different forms. You can have dogs as animals. You can have normally you must represent this arrow like this is a relationship, so it must go up. Then you can have a cat, you can have a mouse. So these are animals. Dog is an animal, cat is an animal, then mouse is an animal. That's inheritance. But what about polymorphism? Polymorphism, we are saying that this animal can occur as a dog, it can occur as a cat, it can occur as a mouse. Hence we have different forms. We have a base class that can occur in different forms. That's polymorphism for you. So that's another example that's not offensive to sensitive people. So let's look at another example, which is the shape. Then with the shape you also have the same vibes. You can have a circle, that's inheritance. Notice that when we deal with polymorphism, you must have inheritance. Without inheritance, you can't have polymorphism. So inheritance is very important. Then you have a triangle, then you have a rectangle. So again, this is pure inheritance. But what about polymorphism? The ability of this shape to appear as a circle, that's polymorphism. Then the ability of a shape to appear as a triangle, that's polymorphism. Then the ability of the shape to appear as a rectangle, that's polymorphism. So we saw, or now it must make sense that polymorphism provides the ability for a method or property or operator to behave differently based on the object that is calling. We'll get to there. But in this case, we are really interested in classes. So we have two types of polymorphism. The first one is going to be runtime polymorphism. Compile time. This is compile time. So we have compile time polymorphism. Then we have runtime polymorphism. So the difference between these two, this one it's related to method overloading. I'm sure you guys remember method overloading. For example, when you have a function int sum that takes two integers, int x and int y, then it's going to return the sum. So it's going to return x plus y as the result. So it's a function that takes an integer, that takes two integers as parameters, then returns their sum as an integer. Then an overload of that can be something like double, then sum, then double x, then double y. Then you can return the sum, so return x plus y. So this is a method overloading because you have a method which has the same name, but how will the compiler know which method to call? It depends on what you pass when you call the method. If you pass two integers, it's automatic that it's going to call the sum, but if you pass a double, it's going to call this other sum. So that's method overloading as polymorphism. You have the same method, but it can appear in different forms. Then runtime polymorphism is the one I was explaining of classes, when you have actual classes. So that's the theory behind polymorphism. Let me see, maybe on the slides they explain it better, you never know. So polymorphism allows objects of different classes to be treated as instances of a common superclass. This definition can be a little bit confusing. Then it enables a single interface, method or function to be used to represent different types of objects. Polymorphism can be achieved through method overriding and interfaces. That's inheritance basically. Polymorphism can be achieved through inheritance in simple terms. It promotes flexibility and extensibility by enabling code to work with various objects without knowing their specific types. So normally it wouldn't make sense because they provide a little theory, because there's no theory. But you can have as many examples as you want. So we are going to move and see if we can let me see, what am I missing? So there's nothing I'm missing. So let's use the shape class. That's the common one. So I'm going to go and create a console application. So in this case, console, next, then I don't know, polymorphism. Then in terms of the folder I'm going to use, it doesn't matter, 272, they are doing OOP also. So then next, then I'm not going to use the top level statement because I don't like that format. I like the old one. So this is going to create the class for us, the form, not the form but the class. So we can add our own classes. So let me add a class on my project. So I'm going to add a class. Then this one is going to be shape. Let me call it shape. So it's going to be shape class, then add. So we are going to demonstrate our polymorphism using the shape class. So I'm just going to change here public. Then it's going to have a few things. So normally all shapes have a name. So let's say, for example, it has a string public So I'm just going to use the property name instead of private variables and stuff. You can also use them, it doesn't matter. Then the other common methods is, so this one is virtual because we want it to be overwritten. Let's say calculate area. So let me see. So here we are just going to, for a generic shape we are going to return 0, so the return type is going to be double. For this one, for the shape 1, we are going to return 0 because we don't know which shape we are dealing with, so the area is just going to be 0. Then I'm going to say public virtual, then double, then calculate perimeter. Even this one I'm going to return 0. So we are just going to use those two methods, and also a method that will display the name, maybe public void display name. Yeah, display name. And I think, or let's leave the display name, it doesn't matter actually. Or let's say public void display. Actually, even that one, void display, which is equals to, maybe say I am shape console dot right line, I'm a shape. So we have this method that will just say I'm a shape, that's all. So notice that this is a class shape that has this name property, then it has 3 methods. The reason they are virtual, it's for inheritance. You know that in inheritance, when you want to override, only when you want to override the method, it must be virtual. We saw why when we did inheritance. Then that's the methods. Then the next thing that we are going to do is going to be, let me see. So we are done with that part. So this is our class. Let's recap how it's represented. So we have the shape class that has the name attribute, then it has the get area, calculate area method, and it has the calculate perimeter method. This is our shape class, so, or entity, those who are familiar with SQL. So we are done. We don't need a constructor because we are going to use that notation, the shortcut notation, the object initialization notation. Then I'm going to add another class for inheritance. We are going to say maybe circle. Then again public. Then circle is going to inherit the shape. So this is inheritance. We know how to do that by now. So this means circle inherits the shape, or circle is a shape. So we are going to override public override double calculate area. Then we are going to actually have some properties. Remember, this is a circle, so it's going to have a radius. Public double radius, we are interested in the radius get set. then we are going to return the area. So this is math.pi because of pi r squared, so radius times radius. So this is the how we calculate the area. We are also going to return the parameter, override double calculate parameter, then we are going to return 2 times pi radius. So this method is going to calculate the area, this one is going to calculate the radius. Then we have another method for display, override. We are still overriding display. Then we are going to console.log, .writeline. This is not JavaScript. I'm a circle with a radius, then we are just going to display its radius. As easy as that. There's nothing complicated so far. This is what we did with inheritance. We are not there on polymorphism yet, it's inheritance. So how is this going to be represented? So we have a circle which is a shape, so we are going to have circle which is a shape. This means it's going to inherit the name, then it's going to inherit the calculate. We forgot the display method, so it's going to inherit everything. Name, it's inherited, then calculate area, it's inherited, calculate perimeter, it's inherited, display, it's inherited, but these are overwritten, so we have new forms of these methods. Then we added an additional property which is the radius. So on top of that we added our own property which was radius. At the end it has these 5 members. So this is our circle. Then we can add other classes just for clarity. Add a class, then I'm going to call this one a triangle. Then in our case, okay, public, because this is a triangle, is going to inherit. A triangle is also a shape, so it's going to add 2 additional properties. I'm going to say height, maybe public double height as the property, then public double base. So, and also it's get set. These are properties. Then get set. So we have those. Then we are going to have something else which is, now we are overriding. Override, we are going to override the calculate area. Then we are going to return the area which is half base times, so it's half base times height. And then we are going to do the other one, override double calculate perimeter. So the perimeter of a rectangle, it's not that easy with, I don't think, is it possible with half? Let me check if we can calculate. Let me go there. Then is it possible to calculate the perimeter? of a rectangle of a triangle given the base and height only. So it's not possible. So let's assume that it's a right angled triangle. So we are going to assume that this is a right angled triangle. So we know that with a right angled triangle, the base is the adjacent, then the height is the opposite. So to get the perimeter, we are going to return all of the sides, which is height plus base, then plus, how do we get the hypotenuse? Square root of height times height, or let me just do the shortcuts. Math dot power height squared plus. So don't care about if you don't understand this, it's not an issue. This is trigonometry, so also base square. I think that should be the case. You just say height plus base plus square root of the hypotenuse. So let's confirm if it's a right angle. So this is a right angle. So base, height, hypotenuse. So I was correct. So you have base plus that plus the square root of those. So we are good to go. Then for display, I'm just going to override the display. Then we are going to console.log or write line. Then I'm a triangle with base equals to, then we can add the base. Or let me do this. I think there's a shortcut of doing this. 0 and height is equals to, then I'm going to say 1. I think this is the way to go also. Then we provide the arguments. Base 0 is going to be the base, then the other maybe we have to represent it like this, I don't know. Base and height. I'm not sure what's the best way to do this. But let's just use F strings because this formatting thing, I don't like it anyways. So we are going to use those ones so that we can just say base and height. So yeah. So we have two different shapes, triangle and a circle. Then you can extend as an exercise. This one you are going to do it as an exercise. So let me see. So as an exercise, you are going to add a new thing, a class called, so we have triangle, rectangle, so rectangle, and you are going to do the same stuff, inheritance, overriding and stuff. So for me, I'm just going to use these two shapes. So we have the other one, which is a triangle. Then we know that it inherits the name, but it adds the height and base to. Then the methods are going to be the same. The difference is that they are overwritten. So we have these two different classes that inherit shape. So how can we do polymorphism? We said polymorphism is the ability of the parent class to appear as the base classes. So I'm going to create an object. When you go to the program, I'm going to say shape, maybe circle is equals to new circle. So that's the syntax. Then we can initialize name is equals to circle, then radius is equals to 3. So that's how you can do it. That's polymorphism. When you are doing something like this, it's polymorphism. So let's try to understand it. Notice that we are trying to create. So here we have the base class. Then here we have the derived class. So we are creating a new circle object and storing it on the shape object. So it's a little bit confusing at first, but we have a new circle, but we are storing it in a shape object. Notice that in this case, the circle it's going to occur, the shape is going to occur as a circle, even though it's a shape, but it's in the form of a circle. So it's polymorphism. So this shape is occurring in the form of a circle. So if we say maybe we want to display its area, console.writeLine, maybe we are going to say area is equals to, then we can say circle.calculate area. So like that. Let me see, what did I miss? I think I did an extra bracket. Then also console.write, or let's call the display method circle.display. So notice that we have circle, the data, its data type, its shape, but we have stored a circle object inside the shape object. When we say circle.calculate parameter, by default you guys are going to assume that we are going to get 0, because when we look at the shape, when we get the get area returns 0, get parameter returns 0, the display method is going to say I am shape. But that's not the case because of polymorphism. What determines the data type is what you have on the right. So when we say calculate parameter, it's going to call, because it's a circle, it's going to call the calculate parameter from the circle class, which is this one. Even when you say display, it's going to call this one. That's polymorphism. At first it's a little bit confusing, but once you get it, then you are done. You are done with polymorphism. You will see that we are not getting a 0. Even the display method, it's going to be radius of 3. But instead, if we had something like this, maybe shape, this is equals to new shape. Maybe name is equals to circle, for example. Then we say console.writeLine, and here I made a mistake, but it doesn't matter. Calculate area. Then here we are going to say area is equals to circle, else dot calculate area. So then let me close here. Then we do the same thing, maybe else dot display. Notice that on the right we have shape, so this means this time shape is appearing as a shape. No confusion. When you say else dot calculate area, we know that in the shape class it returns 0, so we are going to get 0. Then with the other one, calculate display area, it's going to execute the one of I am a shape. Then we can also edit this, and my name is, then we are going to say shape, name. Something like this. So let's execute the code. You will see that with the second one I made a typo. Area is 0, I am shape, and my name is circle. So you see, this is ideally a shape. Shape is occurring as a shape. Here shape is occurring as a circle. Then the next thing is going to be maybe as a triangle. We can say shape, whatever. The name doesn't depict the output. We can name it something random. Maybe item is equals to new, then we say triangle. Then we instantiate the name is equals to triangle. Then we have the base and height. So base is equals to maybe 5, height is equals to maybe 2,5, something like that. So here shape is occurring as a triangle. So when we do these same methods, so when we do these two methods, the same methods on that specific thing, it's going to do the same thing. In this case, we are interested in item. So the name that you give that doesn't depict the actual data type. So you can name it anything. So when you say the triangle ones are going to be executed because item is of type triangle, so it's occurring as that. You will see area is 0. Maybe I didn't override the area, so let's try to see why is that the case for the triangle class. So calculate the perimeter. We didn't calculate area, which is half base times height. So why are we getting 0 then now? Let me check properly. Let me go to program. So it's still showing 0, or it's a matter of the actual types. So let me go to, let's see, half of this times this triangle, calculate perimeter. Or maybe it's because of this, but I don't think that's the case. Let me execute the code. Yeah, that was the case, because half, remember from NF154, when you have 1 over 2, it's integer division, which is 0.5, hence it's going to be 0. So that's why you had to say 0.5 as a decimal. So those are the kind of logical errors. But at the end, you will see that it's using, depending on the type. So if I go to program, this shape here, it occurred as a circle, here as a shape, here as a triangle. So what's the benefit of this polymorphism then, if it's useful? What's the benefit? Remember when we were creating a list or an array, remember we say an array is a sequence. So is a sequence of elements of the same type. Notice that if you have a list, you cannot have an array where you have 2, maybe hello, then true, or something like that. Here you have different data types. So you cannot have a list or an array where you have different data types. But notice that with polymorphism, even with classes, you cannot have an array where you have a circle object, a shape object, maybe a triangle object, something like this. You cannot have something like this. But with polymorphism, we can say, okay, let's create an array of shape objects. Shape, shape, shape. This is the same type, but for each shape we are going to represent it in a different form. For example, this can occur as a shape, this one can occur as a circle, this one can occur as a rectangle or whatever. So this allows us to create a list or an array of items where we have, like indirectly, we have different types because we are using the base class. So here it's sort of cheating, but it's valid. So let's try to do that. So we have an array. Let's create an array. Maybe shape. Because this is an array, we are going to say this. Then shape is equals to new shapes. We can specify the size, for example, for 3 shapes for simplicity. So we have an array of 3 shapes. Because these are shapes, we can say at 0, we can say new shape. Because this is a shape, remember we can say new shape. This is going to create a shape where the name is whatever, maybe shape, then it just has the name. Then at shapes 1 we can create a new circle. This is also valid, where we give it a name is equals to circle. Then we can also say radius is equals to that. This is completely valid. Shapes at 2 is equals to new triangle, where we have a base maybe of 3 and a height of maybe 3.5, something like this. Notice that this array, the data type is shapes. This means in memory at position 0 you can store a shape object, at position 1 you can store a shape object, at position 2 you can store a shape object. Remember that thing of inheritance. In this case a shape is a shape, that one is not confusing, but a circle is a shape, hence we are able to store it as in a shape object. Then a triangle is a shape, we are able to store it in a shape object. So that's the advantage of polymorphism. Even a list, you can create a list of shapes. So you have a list where you can store shapes. Then I can say shapes to the recommended one. So we are creating a new list of shapes. Then we can insert items, shapes to dot add, then new shape. Then we are going to just pass the name is equals to maybe shape 2, for example, something like that. We can keep adding shapes to dot add, then new triangle, for example, where we say base is equals to this, height is equals to this, so it doesn't matter. Then we can continue adding shapes dot add, new triangle, it doesn't matter which one you add. So circle, maybe radius is equals to 4. So that's the advantages of polymorphism. You can do this. You can create arrays or objects of different types because of polymorphism. Because a triangle is a shape, we can add it in a list of shapes. Same with arrays. So even looping through, let's loop through the array. Then for each we are going to say shape. In shapes we are going to just say shape dot display, and you will see what's going to happen. Because this is a shape, we are expecting that thing I'm a shape, my name is shape. Then this one, because it's a circle, we are expecting I'm a circle, my name is what. Same with this one, I'm a rectangle, and something like that. So let's give it a name also, a rectangle. Then same with these ones, I mean triangle, sorry. So it's triangle, then triangle. So we have something like that, and name is equals to circle for this one. Yeah, we can have something like that. So when I execute this, as I said, that's what I'm going to expect. I'm a triangle, it starts here because the list start on shape. This is the previous output. I'm a shape and my name is shape. Second one, I'm a circle with a radius of. I'm a triangle with a base of. Then we can do the same thing for the other list, or for the list we can do the same thing. Let me comment this one out, and also let me comment out these so I'm going to comment out this just to expect one output. So when I execute this, I'm a shape and my name is, I'm a circle with radius, I'm a triangle with So though that's the beauty of polymorphism. So I think that makes sense. I don't know if it doesn't make sense. I'll send another video to watch. Me normally it wouldn't make much sense in the beginning, but the problem is time. So we have to cover interfaces. So there's no time actually. So let's do interfaces and also abstract classes. There's a lot to cover. So let's cover abstract classes, which are a little bit quick. So we have abstract classes. So these ones, they enable abstraction. Then the important thing is that abstract classes, they can have two types of methods. You can have abstract methods, then you can have non-abstract methods. So that's the important thing. They can have abstract method or non-abstract method. So what's the general syntax of defining an abstract class? You are going to do your public, or if it's private, it's private. Then instead of class, you are going to say abstract. Then you put the class. Then you give it a name. Then you have the rest of the things here. Then when it comes to the methods, we have abstract methods. So abstract methods don't have a body. Then these ones, they have a body. So we are going to, I think it's easy with an example. So I'm going to use the same shape example. So I'm going to remove all the code that we have. That was for the other type of. So now we are going to implement this as an abstract class. So I'm going to say public abstract, then class. That's how you indicate that this is an abstract class. Then instead of the virtual, we are going, you see these methods indirectly, they didn't have any implementation. So hence we are going to make them abstract. By abstract, we are saying there's no body. It ends with a semicolon. Then instead of virtual, we are going to say abstract, like this. This means this method is not implemented. Then same with this one, the method is not implemented, so we are going to remove that. We are going to make it an abstract method. This one is implemented because it does something like a real thing, so we are not going to override the method. So that's an abstract class. Then another thing with abstract classes is that you cannot create an object. For example, I cannot say shape, maybe shape is equals to new shape. This is not going to work at all because this is an abstract method. It's not fully implemented. You see, cannot create an instance of the abstract type or interface type. So this thing is not fully implemented, hence we cannot create like objects of that class. That's the other important thing. So with abstract classes, you cannot create objects of an abstract class. So that's important. So as we saw, it doesn't work. So okay, if we can't create methods, then what's the use? So basically an abstract class is used to define like some properties. So as we said with abstractions, it hides the internal implementation. So as you can see here, even a person who has access to this class, they don't have any idea of how these methods are going to be implemented because they're abstract. So the implementation is hidden from the user. So that's an abstract class. First thing first, keyword abstract, then class, whatever name, then it must have abstract methods or non-abstract methods. So anyhow, then now let's go to the circle. We are going to implement the abstract class. So it's going to be the same thing as inheritance. That's how you implement an abstract class. You inherit it. Then the rest is going to be the same. Nothing changes. We are going to override the abstract method. This means we are implementing that specific method. Hence, we can successfully create the circle objects. Notice, even after overriding, we cannot create shape objects because it's an abstract class. So the rest remains the same, but the difference is that now we don't have that ability of saying shape what is equals to new shape. That one we don't have. But other things like polymorphism, they are still there. And also like creating objects. So let me say you can create normal circle objects. Circle is equals to new circle, name is equals to circle, radius is equals to 5. So that one doesn't change, is equals to whatever. That one doesn't change anything. The way it was behaving previously, it's the way it's behaving now. So the only difference is that now we are using an abstract class. Everything works the same. The difference is that the shape is no longer there as an object. Then we can say, let's just use the circle.display. Then you will see that it's going to display I'm a circle with a radius of 5. We can do things like calculate area and stuff like that, so you know how it works. Then another thing that you can do is polymorphism. Shape, notice that this one is not valid, but if I say shape is equals to new circle, this is valid. Name is equals to whatever, then the radius is equals to whatever. So notice that this is valid because we are creating this shape object is appearing as a circle object. Hence, there's no new shape. As long as there's no new shape, that's a valid syntax with abstract classes. So we can also do polymorphism. We can create the circle normally, or we can create the circle using polymorphism. Then the rest is the same. The only difference is that you cannot have objects of the circle, of the shape class, or of the base class. So those are abstract classes. There's nothing fancy to them. Like, they are very straightforward. So let's move to the next concept, which is interfaces. I'm sure I'm not leaving anything. Yeah, same with the triangle. Also shape, maybe triangle is equals to new triangle. Then you can give it a name. Then you can give it a base, then height. So this works. Alternatively, you can actually use the actual triangle class. That one doesn't change anything. But what you have to notice about abstract classes is it's that when you create them, when you create an abstract class, you have this keyword abstract methods. These are methods that don't have implementation. They have the keyword abstract, they don't have a body, so they can have parameters but they cannot have the body. They are not implemented, they are abstract. So those are abstract classes. So we are done with abstract classes. There's nothing much, you just have to know the syntax of how to create them. Then the other thing is interfaces. So let's move to interface. Interface classes. Interface. So with interfaces, an interface is just a contract. So it's a contract that defines a set of methods. You can say properties also. It can be events and other things, maybe indices. You guys don't care about much, you only care about methods. It defines a set of methods without providing implementation, without providing implementation. So if we look at this class, the shape class, mostly we don't really care about the name. So in general, with the shape class, if we don't care about the name and make it something like this, like we are not implementing anything, so you can do it like abstract. Everything is abstract, so you don't care about properties, you don't care about anything, you just care about these methods. So you can define that class as an interface. So first thing first, we are going to say interface here. Then the next thing, we are going to remove these. Let me see. So let me see. So you have an interface. So this is no longer a class, it's an interface. So we are this is not a class. An abstract class is a class, an interface is not a class. So this is an interface. We are just defining a set of methods that are going to be shared among child classes without actual implementation. This is just a contract, this is just a description. We don't have any implementation. Then we thought, notice that if you just say class, this is not going to work. It has to be an interface. So those are interfaces. So another important thing, let's look at the properties of interfaces. So properties for interfaces. So you will notice that you only have declaration only. This means you don't have any implementation. These methods are declared but they are not implemented. So that's one thing that you should notice. Another thing is that implementation requirement. Requirement. This means you have to implement interfaces. So you must implement them. This means there must be child classes that implements the interfaces. So we'll see how it works, that one. Then the next property that you can have is that you don't have constructors. No constructors. Interfaces, you will never have constructors. Then the other important thing is that you don't have fields. Those are your data attributes. You don't have data attributes. Something like, if I say int, for example, int a, this is not going to be valid. You will see why. Interface cannot contain instance fields, but you can have properties like int a get set, but you cannot have variables, so, or fields. Then the next important thing is that access modifiers. So access modifiers, you don't have. No access modifiers. By access modifiers, you know we are referring to private, public, internal, what. So we don't have that. Protected, we don't have that. So if you put that, you are going to have an error. Then the next thing, by default, these things are public, so you don't have to put access modifiers. Then the other important thing with interfaces is that the class or the interface actually must start with the letter I. So by default, so this is not valid, like this is up to users, but as developers we agree to certain standards. So for all developers it's recommended that you start your interface with an I. So you will see. So that's how you do an interface. It's interface, you put an I, then you put the name of the interface, then you define whatever methods you want your child classes to implement. So in this case we can look at this. You will see when you go to Circle, in terms of inheriting, it's the same I shape, implementing the methods, but you don't have this thing of override. So that's the other important thing. With you don't override because they were not implemented, hence you just have to do that. So another thing that we notice now is that no override. So override on child classes. So you cannot override. So you just have to implement the methods. You are not overriding because they were not implemented. Hence you have something like this. Then other than that, everything is the same. You can add additional attributes and stuff. So same with the triangle, we are just going to fix, then we are going to remove the override. Everything works the same. Then we remove the override, then everything works the same. So with the circle, what did I do with the name? we no longer have the name property. So remember, we are using an interface, hence we no longer have the name property. It's gone. So the name property is gone because these are interfaces, so we no longer have that property. Then remember, here it's I shape, so it works the same as abstract classes. The difference is that we have like certain restrictions to the way we create them, but instead of in terms of working, they work the same. I don't think you can have an abstract class, for example, I shape, maybe shape is equals to new I shape. That one, it's not possible because of that. You cannot create an instance of the abstract or interface. So that's an abstract class for you. They work the same in terms of inheritance. The difference is that with so I think it's very important to differentiate between the two. So let me just ask there, differentiate between we are going to stop it in a table. We don't want to read. So let's look at the difference between the two. So definition, we saw that an abstract class, it's a base class that cannot be instantiated. This means you cannot create objects, and can contain both abstract and non-abstract members. We saw that interface is a contract that defines a set of methods, properties, events, or indices without any implementation. Then in terms of members, they can have fields, properties, methods. These ones can have those attributes, can include, and constructors can include both abstract and non-abstract members. This one can only have methods, properties without any implementation. So no fields or constructors are allowed. In terms of implementation, method implementation can provide complete and incomplete. We know that if you didn't implement the method, it's abstract in an abstract class. But with the other one, you cannot provide any method implementation. So let's see if we can try to violate that rule. On the shape class, let's try to do that. Maybe a random method, void hello, we are going to implement something like that. But I think this was until .NET you can do that apparently, but ChatGPT is specific in terms of the model of C#. Now in 8.0 you can do that. Methods were introduced. Now you can do that. This is an old concept, but as we are sticking to the old one, we cannot provide any implementation. Then access modifiers, this one can have public, protected, private and stuff, but these ones, they are implicitly public and cannot have any other access modifiers. Constructors, we know that this one can have, this one cannot have. Inheritance, a class can inherit from one abstract class, but for interfaces you can inherit from multiple interfaces. That one we are not going to look. A multiple inheritance, we are not looking at it. Then here they are just explaining other things, but you saw the difference between the two methods. what you must know is the syntax of how to create one and how to implement one. So I think we covered everything when it comes to these classes. Let me see. Interfaces: a blueprint or contract defining a set of methods and properties a class must implement, establishes a common set of behaviors that multiple classes can adhere to, promoting code consistency and providing a way to achieve polymorphism. And these ones are just the definitions, but as you can see, I'm sure you can analyze this code by now. I think any code from this, now you should be able to analyze any code in general. So I think we'll end here for the 4 pillars of OOP.